Okay, let's get started on why there is same amount of positive integers and positive rational numbers. So let's just define very quickly integers. Where let's call it z first, and let's do 1, 2, 3, 4, and so on. And then we can define rationals, which is q. That's 2 plus for positive rationals, and now we're gonna write them as the ratio of two integers. So let's get rid of that such that m and n are from our integers, and they're in the simplest form. So GCD of m and n is 1. We're just gonna let these two be the sets that we're comparing to each other. So we're gonna define a function. That is the voice of my dog, the sound of my dog. So we're going to define this function. The height of a number x is going to be, or let's do the height of some m over n. Height of a rational number is just m plus n. So the numerator plus the denominator. And now we're gonna figure out what numbers have different heights. So we're gonna search for 1 because 0 is not possible. So what numbers have height 1? It's just 0 over 1. What numbers have heights of 2? It's just 1 over 1. Heights of 3, we have 1 over 2 and 2 over 1. And that's about it. So heights of 4, we can have 1 over 3 and 3 over 1. Note that we don't put 2 over 2 because that's the same as this 1 over 1. A couple more heights. Numbers that have height 5, 1 over 4, 4 over 1. And then we have 2 over 3 and 3 over 2. That should be about it. And let's just do 6. 1 over 5, 5 over 1. Do we have 2 over 3? Sorry, 2 over 4. 2 over 4 is not simplified. 4 over 2 is not simplified. So for 6, that's it. And 3 over 3 is still 1. So, and we can go on like this and do it. So what's the point of doing this? If we see we have all the rational numbers here, we just constructed so we constructed all of the positive rationals here by this sequence of h. Let's say by this sequence we have constructed all of them. Now we're gonna do something fun. We're gonna number them, this number. So let's go with M for Madi. This is M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, and so on. So we can also number them this way, or we are numbering them. We're making a sequence out of them. So what is the point of doing this? So the point is that we are just we just counted them with integers basically. So if you note, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. So there's literally a one-to-one correspondence between integers, which is the subscript, and the rational numbers, which are what we were counting. And we said that these are all the rational numbers that we constructed all of them, and we are counting all of them. So we have the same amount. There's a one-to-one correspondence. One-to-one correspondence between integers and rationals. So we just did the positive case, of course, but it's trivial that it extends to both cases to negative numbers as well. So the amount of integers is the same as the amount of natural numbers, rational numbers. Yeah, and they're both infinity, but they are the same type of infinity, which is not the same infinity as the real numbers. This is not the same. These are countable infinite. We can clearly count them. This one is uncountable. Damn, it's already too much S2T. Oh, let's put some glasses for her. Yeah. Thanks for tuning in. And good luck on chem exam. If you're watching this before your chem exam, and if not, good luck on your Calc 3 exam. I think it's Thursday, you said. But yeah.